Hey guys, Sam from JKI here, Senior Staff Software Engineer. Today I wanted to share a recording of a training session that explores implementing the sequence engine using the JKI State Machine Object or SMO framework. We start from an existing application that's utilizing a I/O manager hardware abstraction layer, and then we expand on this to add the sequence engine. In the first half of the video, we walk through creating the SMO from scratch, integrating it into the existing system. This is great if you're new to SMO, as we highlight a lot of the core foundational concepts. In the second half of the video, we implement the sequence engine. So if you're familiar with SMO, feel free to skip to the second half to see that implementation. This session was really fun for me. Not only do we cover the implementation of the sequence engine, we also discuss foundational LabVIEW concepts. We explore design and architecture decisions. And you also get to see how I code. I can warn you it's a bit fast at times, so feel free to pause. And you're also going to see a little bit of JKI style sprinkled in there. But yeah, I hope you enjoy. Let's get into it. So let's just make sure we can run that data. Okay, we're online. Boom, cool. So it's simulated data, but it's data. Great. Okay, so first things first, we need to create our sequence SMO. So we're going to go to Tools. We're going to go to JKI State Machine SMO Editor. And so, yeah, just as a kind of reminder here, we are creating this subsystem. So it is going to depend on the I/O manager, and the user interface will interact with it through its public API. Its public API is going to be a couple things. And again, I'm just kind of filling airtime while this loads. The public API is going to be set. So we're going to do something like this, right? So it's going to have the sequence file location, right? We're going to need to know where to look for files. And then with that, we can have a public API, which is designated by this plus get sequences, get sequences. And then we have load sequence. So I'm going to look at the folder. This is actually a folder. And then it's going to tell me, hey, you have sequence 1, sequence 2 available. I found those files. And then I'm going to call the load sequence, and I'm going to specify like sequence 1, right? And then, of course, I have run sequence. And if we're feeling extra spicy, we can add an abort sequence too.
Can I ask one other thing? As it's running and progressing through that sequence, it might take an hour or a day. Is there a way to have like a load, like current cycle, or I guess how do you recommend tracking where we currently are, what's been done, what needs to be done? Does that make sense?
Yeah, absolutely. A great question. So that would be basically the sequence would have a status. So we would have get status, and then we would also have public event status. And so we would need to define what the data structure of this status looks like. And we may or may not have time for that. And basically the way this works is as the sequence engine is going through each step, it's going to publish. Let me just close these guys. It's going to publish this public event that is status. And so the UI can listen to that event, and the UI will automatically update as the sequence goes through. But it's also important to have this get status because, well, this is a bit more advanced, but basically there's race conditions, there's situations where you might miss the event. Right. With your architecture, it's very unlikely that that'll happen, but it's always good to have an ability to get it rather than just to receive it.
Absolutely.
But yeah, great question. And again, we're going to take this just baby steps. We're going to do one thing at a time. So we'll probably add, the abort and the status afterwards. But first things first. Let's just get some things on the board here. All right. So we've got our SMO editor, and what we're going to do is we're going to hit the plus, and then we're going to just make this an SMO basic. We don't need anything really. Yeah, it comes with a process and a launcher. Great. And then we'll just call this sequencer, I guess. Unless you guys have a better name. And then we'll hit create. So then we're going to go ahead and throw this in here. First things first, we need to launch it. So we go to our launcher. And remember, the launcher cascades things from the bottom up, right? First, we declare our drivers. Then we declare IO manager. And again, if we go back to our handy dandy UML, we'll see that the sequencer is on the same level as the logger. This might change if the sequencer needs to set the log rate, but we can cross that bridge later, right? You might eventually have something like this where the sequencer also can send commands to the logger, but again, a little bit more advanced. So we're going to put the sequencer at this level here. So the way that works, again, same thing with the IO mods, we're just creating a new SMO. So what we're going to do is we're going to take our sequencer class, we're going to plop it down right here. Very, very good practice to go into the sequencer and change the banner so that we know what we're looking at here. So let's do like, I don't know, purple. So then we're going to color that, and we're going to get rid of this, and we're going to say sequence. And I like white, so boom. Great. So now it's very clear that this is the sequencer class. And if you're feeling extra spicy, you should also change the icon, but to save time, I'm not going to do that. So every SMO, you have to call the SMO create, right? It happens here, happens there. Great. So then what we need to do, again, handy dandy UML, we need to give the IO manager to the sequencer, right? Same way the logger is getting the IO manager, we need to basically replicate this. So if we look at the logger here, we see a couple things. We see inside of the logger, it stores this class or this cluster called dependencies. And then we have the dependencies.set function. And that's this guy right here. So we're going to do that exact same thing with the sequencer. We're going to go to sequencer. We're going to say new type definition, fuse cluster, and this is going to say dependencies. And then we're going to give it the IO manager, which is up here. IO manager, bloop. Great. So now we have this guy. All right, save that. Dependencies, and this is a JKI style. Is when you save type defs, we do dash the type, just because. But that's just kind of, yeah. All right, so then let's create a new folder. Let's just API, and then we'll do new VI from static dispatch. And we will call this dependencies.set. Great. And then it's going to take in our dependencies cluster, give it an icon. I'm pretty lazy about these, so we're going to do a write, actually, and then a depend. Great. And then Control U to clean it up, and boom. Now we have our dependencies. And actually, no, we're going to need, so we're going to go grab this guy here, pop that down here, get our bundle, and then we are going to feed that. We're going to give the same IO manager that we gave the logger, we're also going to give it to our sequencer. So now the sequencer has access to the IO manager. You can imagine this is how we're going to be calling these writes. The IO manager, we haven't really explored that too much. As a very simple API, io.write. And also, and we want to clean that guy up. There we go. Yeah, so it just calls the write. And this is, again, part of the framework. You don't really need to worry about how it works. That's kind of one of the beauties of object-oriented programming. It's this concept of abstraction. You don't need to worry about how it works under the hood. You just need to know it does what it says it will do. So we can read, we can write, we can read many, we can read all. Okay, so now we have created our sequencer, and then there's a couple more steps here. So one, we are going to give the sequencer to our error manager. And actually, we should kind of update this so that, whoop, right? So if the sequencer has an error, it's going to, because of the framework, it's going to automatically publish that to the error handler, and the rest of the world will see it. So in order to do that, that's right here. This is the error manager. Very similar pattern here. The error manager has a list of dependencies. So we're just going to go ahead and bloop and give oops here to this array. We're going to stick it right there. So now the error manager is also monitoring the sequence engine. And then the last step here, well, one of the last steps is to start the process of the sequencer. Okay, so we're just going to go feed that right there. And this happens, so this is kind of like a order of operations. We want to start the error manager first, notice we're calling this start here, and then we call the start for all of the other subsystems. That's because if there's an error on startup of any of these subsystems, we want the error manager to be running so that it can catch it right away, right? And not miss it. And then a couple of just housekeeping things here. We are going to plop the sequencer, again, remember the ordering of the errors that we discussed yesterday. We're just going to do that. And then kind of same thing here. We are going to put that down there. And then one last step here is we're going to update this type def. So this type def is used by the UI to have access to all of our subsystems. So this allows the UI to send logger commands, read and write from the IO manager, receive the error broadcast from the error manager. And so what we're going to do is we're going to also add the sequence to this class and just kind of and then to this, it's not even a class, it's just a cluster. So then I go here and I add the sequencer and we plop that right there. And so just to give you how this works. So this is now, that's it. That's all we had to do to the launcher. I know that was maybe a lot of steps, but really it just boils down to this.
Perfect.
And then feeding it to the error manager and then feeding it here. So the reason I did this might not be immediately obvious. If we go to where this is called, this is the UI, right? And when the launcher is called first thing as part of the UI, and we return this subsystems class and we store it in the shift register of the state machine so that, for example, if I hit send command, I can then go grab out of subsystems my IO manager and call the IO manager write function. Same thing with the read, right? The actions read, we just looked at that. Did I not fix this? Oh, this is on, we switched branches, that's right. Anyways, again, call the IO manager, read. You can also see in events register, we're calling the logger SMO, and we're getting the logger events, which is the fact that an error happened, right? And we get that event, and then if we go to our event manager, we have this event right here, which is an error occurred at a subsystem, and then it does some processing and it puts it in the console. The logging for errors happens in the error in the error manager itself. So this is just for notification and display. So similarly, we talked about the SMPT notifications. You would have that condition monitor system that depends on the error manager, and then it would listen to the error manager events. When it receives that event, it would, instead of displaying it to the UI, it would send out an email. Questions so far?
This is beautiful. I love the way it's all coming together.
All right, so let's write ourselves a little sequence. So I think I'm going to step away from the main UI, and we're actually going to leverage the sequence. We're just going to write the sequence in isolation, and I'll show. Hopefully, this will kind of introduce a new concept, which is the test launcher, right? So you've probably seen these floating around, but basically, the test launcher allows you to run the sequencer by itself. So if I run this, it calls the create, and then it calls the start, and here we're running. And if we go to our sequencer process, we can see this is also running as well. It's locked right now. So if we go to view, browse relationships for intern items, this will open up the clone. We talked about clones yesterday, right? And now you can see this is actually running. And so this is the sequence process where the sequence engine will run. So let's get to it. So I'm going to go ahead and stop. All right. So first things first, let's save this sequence file. And let's just put it in our, let's just do demo sequences files. I don't know. And then let's call this sequence 1, and we're going to call them .seq. So that they have a specific file extent. No, we're not. We're going to call it CSV. We're going to be good about that. Great. So we have sequence 1 CSV, and then we also have sequence 2.csv. Great. Easy enough. So then we're gonna go, and we're just gonna go start to build this API. So the first API is get sequences. Okay. So what does that look like? We're gonna do new API from static dispatch, and what this is gonna do is it's gonna take in a file path. This one here. It's gonna say sequence folder. And then we're going to save this as sequences.get. And then it's going to return a string array of sequences. Hold on. Okay, so I am kind of just designing this on the fly, so I might backtrack a little bit, but generally what this is going to look like is something like this. So, okay. What we're going to do is we are going to give it a sequence folder, which is in here, right? Boop. And what we want this to do is we just want to return a list of sequences. Okay, easy enough. List folder, that's what I want. All right, pattern is the same. And then we're just going to run this and kind of see what we get, right? Okay, boom. Look at that. It returned us the sequences. And then just as a sanity check, let's do this, but let's name it .txt. Great. And it doesn't show up. Perfect. That's what we want. All right. So then what we're going to do is we're going to delete these, and we can just return these file names, but let's clean it up a little bit, right? Instead of returning the .csv, let's just do this.
Hey Sam.
Yeah.
If you want to speed up a little, like you're kind of going a little bit slow right now, you can pick up the pace if you want.
You're joking, right?
No, we're just smiling, enjoying watching you do this. This is awesome.
Man.
This is like 10
okay. Yeah. Strip path. Or no, strip file path extension. And we just want the root there. And so now this will just give us a nice little sequence too. Okay. And what we're going to do here, clean this up. Style is important. Great. So now we have an API that tells us the available sequences that we want. And I'm actually going to do a little bit more here. We're going to, just to black, get sequence. We're going to do a space. We're going to do a read. Oh, great. Okay, and then I'm actually going to go one step further. This will be clear in a second why I do this, but I'm going to save this sequence folder inside of my class. Just delete the default data there. So I'm going to make that as part of the private data. Oh, hold on. Quick detour. I forgot to implement the dependencies.set function. So we're going to do that. We're going to put the dependencies in our private data. And then as part of the dependencies.set, we're going to just stick those in there. Sorry, I should have done this when we first implemented this. Save that, close it. Great. Dependencies, boom. Great. Control space, Control T. Clean that up, get that over there. All right. So that's just a quick fix. So the reason I remembered is because we just added that to our private data here. And as part of the sequences, actually, yeah, we're going to do this. We're going to store that sequence folder, and I'll show you why in a second. What we can do here now, so we go back to our test launcher, and we can test this API, right? So I'm going to go in here, and we're going to add a button that is the file path control, right? So this is sequence folder location. And then we'll just go in here, we'll add an event for the sequence folder location on value change. And on value change, what we're going to do is we're going to call our function, right? And then what we want to do here is we want to make sure we pass the class via shift register, because what we just did here in this function is we stored the sequence folder, right? And so we need to remember that because it's going inside the class. So now we need to make sure this class is wired through everywhere. So I'm just going to go quickly do that. And when we implement this in the UI, it'll be easier to do. Well, yeah, you'll see. Okay, now that notice this, that icon here went from kind of like not all the way filled in to filled in. So that's important. All right, so then when we change the sequence folder, we're going to call that API, right? And let's wire the errors, good practice. And then we'll output the available sequence. So let's demo this one more time. So sequences are blank. Go to my sequence folder. I select demo sequence files, select folder, boom. It called my API. It read the files. Now I have this. So the reason I'm showing you this is because we will do this on our UI. On the main UI, we're going to do exactly this pattern. And if you recall, so we're going to do something very similar to the way these drop-downs work, right? We're going to populate this list of available sequences based on this list here. And then a user can select the sequences. And again, as a more advanced feature, we'll look at how to run multiple sequences to chain them, but that's probably not today. All right. So we have the available sequences. Great. Now we want to call, and I'm actually going to simplify our UI. We don't need load sequence. We just need run sequence, sequence name. Great. So the way this works is we're going to do the same thing. New API, static dispatch. And things are going to get a little bit more complicated. So buckle up. Sequence dot run. Okay. Straightforward enough, and it is going to take in a sequence name, right? Sequence name. Now, remember, this name is just this path plus this plus a .csv. So then what we can do in here change that to control, remove this guy, is we can generate the file path of the sequence with a build path. What is it called? Is it build path? Yeah, build path. So we take the sequence folder that we stored earlier, and we have the sequence name, but we also want to do a format into string because we want to take that string name and we want to add the .csv back. So we're going to do %s, which is just this string .csv. So then we do that. And then we do this. We're gonna switch to the main UI. It's gonna make our life easier in the future. So I'm gonna go and do a quick pivot and just implement what we just looked at on the main UI. Right? So I'm gonna just, for the sake of, so this is now our sequence playground. So this is the sequence directory. We're going to have a drop down for the sequence select, and then we're going to have a run sequence button. And you'll kind of see how this all plays out here in a second. Okay, so we're going to go implement exactly what we just had before, which is I always go to the timeout frame and I duplicate this one is my strategy. And then we're going to go sequence directory, so on value change, and then we're just going to delete this code because we don't want that. And we're going to call that function that we just wrote, the sequence.run, or excuse me, not the sequence.run, sequences.get. And this is going to take in our sequences directory. And then we're going to do an unbundle. We're going to get our sequences, subsystem sequence. And remember, the thing we did last time is we had to wire that class back into the shift register. So we're going to do the same thing, but this one's a lot easier. I only have to do it in this one place. So I go to my subsystems, I go grab my sequencer. Great. So now I have that there, style. And then what we're going to do here is, so now we have this, remember this array of sequences. What I'm going to do is I'm going to populate this dropdown with that list. So I'm going to do create property node strings. And now that is how that dropdown gets populated. Cool. Now I can implement the run sequence, and now because now I'll have a drop down of my available sequences, and so then when I click run sequence, I have that sequence right there. So then we're going to do same thing, timeout, duplicate case, run sequence. Great. Best practice to put the button in the event structure, and then we're going to call signature select. And this, while we just fed it an array of strings, that's just the available choices. Its value is just a single string. So then we're going to call the sequence run function. Right? So same thing. We're going to go grab this guy, paste that there, and we're going to feed it our sequence class. I forgot to wire this up. Great. Okay, so let's run this. Get her back online. All right, and we are online. We've got data. So again, I'm going to go select my sequence directory. What's right here? Select folder. And now we have our dropdown of sequence 1, sequence 2. And then I can click run sequence. And what we see happen is this appended path gets updated, right? Probe on that. And if I change to sequence 2, run sequence, we have sequence 2 there. And then again, change back to sequence 1, change to sequence 1. So obviously this is not running the sequence yet, but it's getting us the file. And so when I come back, we're going to start looking at how do we actually run or tell the system to run the sequence. Notice we haven't even implemented the sequence engine yet, but we're just kind of putting in the piping to get there. All right. Now I should have done this when I took the break because we need our SMO editor back. So this is where things get a little bit more complicated. While this is loading, notice in the sequence run, it's happening what we call inline. It's happening right here, right? The action is happening here. But to run the sequence engine, we want to run that asynchronously, right? We want to run that in the process. And you guys are familiar, these processes launch asynchronously. So we want to do a couple things here. I'm just going to clean this up a little bit. We want to send a message to the process that says, run the sequence, and we're going to run this file. And later, we can send an array of paths as well. Or, we can send a meta sequence, basically, that, this one here, that then instructs the sequence engine to run several with this information. So that is actually, I think we can go till 11, and because we're gonna need a little bit more time. We're close though. I think I can do this.
Yeah, dude, great. Now that we're not distracting you.
Yeah. So we got a sequencer, and we create new event. And this is actually going to be a private event. It's private because it's a communication from itself to itself. The status would be a public event because that would be a message from the process, right? Broadcasting the status outward to like the UI, for example. But in this case, we're going to do private event, and we're going to call it run sequence. Well, so properly sequence.run is the JKI style. And then the data is going to be the path. So this is the sequence path. And then we hit create, and the magic is going to happen. And so, I want you guys to, be thinking about how to like extrapolate this, and how would you take what we're doing for the sequencer and do something similar for like the condition monitoring system. So, all right. So it's done working. I'll go ahead and minimize that. And you see it did a couple things here. So if we look inside the class, now it added this private events little bundle. It added a couple methods for us. Get private events. Great. And it may have, no, it didn't add it here. So what we're going to need to do, we're in the process. We need to listen for that event. So that happens in the event register frame. So in the event register, we're going to call get private events. I'm going to give it the class, and we're going to pull this guy down, and then we're going to wire that up. And then we'll add it to our error list here. So, okay, so we've added this private events to our event registration, which means we can go to our event case structure, duplicate event, and now we have our private events sequence.run function. Awesome. So then we're going to get that, and notice it gives us the path that we asked for. Okay, we're getting close. Next step is we have to send this event to our process. And so we're going to go back to our sequence.run function, and we're going to call get private events. And then we're going to unbundle it, and we're going to get the sequence.run event. Again, that's what we just created. And we're going to say fire generate user event. So this is how you send events. And notice this event data is the data type that we expect, which is the file path. So then I can just wire that in there, and it takes a file path. All right, so let's demo this real quick. So we're going to go to main. We're going to spin things up. And we are going to look at our process here. So this is our sequence process. And if we go again to our clone of it. So this is the actual one that's running, as noted by the arrow there. And if we did our job right, when I first, so there's a little bit of we have to select the folder. And you know what, well, we can fix that in a second here. We are going to select sequence 2. We're going to hit run sequence, and boom, this guy populated. This guy got the event. If we switch it to sequence 1, so now our sequence is receiving that message from the UI. Awesome. And I am going to do just a little quality of life thing here. You notice when I ran this, I selected the sequence directory again. That was such that I called the load to populate this sequence folder. So what I'm actually going to do here, I'm going to do this. Okay, so we're going to actually move this frame out of here. You'll see why in a second. So this is actually better practice in general. So we're going to just plop that down here. And what we're going to do is we're going to say sequence load. Neat. Great. And then we're going to add an action here, which is sequence load. So now that event will call this frame. We're going to just stick this code back in here. The reason I'm doing this is so that on UI initialize, remember when state machines run for the first time, they call macro initialize. So in macro initialize, I'm also going to call sequence load. And that way it will automatically populate this data with whatever the default value of this sequence directory is. So we can do data operations and make current value default. And then that way if I wipe this, so now if I run this, I don't have to reselect the sequence directory. It's just going to remember that. Then I can select sequence 1 and run that and so on. Cool.
Yeah, getting the right defaults is nice.
Yeah, and like this eventually could be a configuration value that you could read from file, right? There's a whole world there, but we can only do so much. All right, so we are very close, sort of. What we've done thus far, just to recap, we created the class. We created the dependencies setter, right? The dependencies.set, so that we could give it the IO manager, which we'll need to be able to set these values. And then we also created a couple APIs to load the sequences so we know which ones are available and to run the sequence. Now, obviously, we're not running yet, but we've told the process to run. So what's that look like? All right. Buckle up. We're in stage 2, maybe even stage 3. All right. There's a couple things that we're going to need to do. This might not be obvious why I'm doing it, but hopefully the pieces will come together in a second here. But believe it or not, I've written a lot of sequences before, so I know I know it needs to be done here. We're just going to clean this up. This is just my habits. Okay. So we are going to need a false constant. This is going to be sequence running. Then we are going to need a numeric constant. This is going to be sequence start time. We will also need a file path. The constant. Why? Man, LabVIEW. Copy, paste. Great. We don't need that to be a type def. And this is just our sequence path. And then we will eventually need we will need a Okay, well, I need a sequence next index. Again, you'll see why in a second here. And then we're going to need a new type def, which will be a fuse cluster that is going to be the data structure of our sequence, right? So that's going to have a numeric for start time, and then it's going to have a channel, a string array of channels and a numeric array of values. So you can see this data structure matches this data structure, right? So this is sequence step. So then we'll say this is sequence step cluster. Great. And then we're going to plop this down, and then this is actually going to be an array. And then we're just going to do this as the sequence.
What did you do to make it an array?
I just right-clicked and said change to array.
Oh, cool. Oh, that shortcut.
Yep. So now this is all of our steps. And what you'll notice here is that actually this data structure actually combines. This is a single step, right? Because it's there, they all start at 0. All right. So next step, we need to load the sequence. So we're going to go over into our actions. We're going to do sequence load. And for this one, we're actually going to create a sub VI. And so for that case, we're going to do new virtual folder private. Oh, we already have a private. Lovely. We're going to new VI from static dispatch. And then what we know, sequence.load, is it's going to take in a file path, use, and it's going to output, can you guess? This, right? So now we have to parse our sequence file. And there's a lot of considerations here. I'm going to do it, for the sake of time in kind of a dumb way. Actually, we'll see. We'll see. First things first, read text file. Great. And the beauty of this guy is we can go to our sequences and we can just run this and test it kind of in line. Cool. So now we have our sequence data. All right. Next step, spreadsheet string to array. So this allows us to convert the single string into a CSV string. Great, and the data type here is going to be an array of 2Ds. So then again, just kind of step by step, that I do this even as an experienced developer, boom. Okay, great. Now we can see I have my data in a nice little structure here. I don't care about the first 2 lines. These are metadata, so I'm going to delete them. Delete from array. Boom. The length is going to be 2, and the row will start at 0. And so now if we go look at what our array looks like, boom, there's our sequence. All right, easy enough. All right, so then what we're going to do is something a little bit more advanced, but this robustifies it. What I'm going to do is it's actually going to put in a fix, if you will, for user error. So if a user types in this, right, 500 comes before 300, and that's not correct, chronologically. And if you remember in our sequencer process, right, this is just an array, and it's going, when we get to implementing it, you'll see this needs to be in chronological order. So I'm going to do a little bit of a trick here to parse this data correctly. So we're going to loop over our array. And what we do know, dude, why does it do this to me? For up until LabVIEW 25, index array was the first one, but they added a new one. So now my muscle memory is
muscle memory.
Yeah, I don't know why they like, and that's such a common, whatever. All right, so now we know for every time I loop over this, I'm going to have 3 elements in it. The first one's going to be the time, the next one's going to be the channel name, and the third one's going to be the value. So what I'm going to do is I'm going to kind of sort this as I parse it. And I'm going to do that with a map. Maps are kind of my favorite data structure. So we're going to, and this, I'm going to kind of do this in a weird way, but you'll see when it comes together. Put in map, what is it called? Map. I don't know, man. Insert into map. Okay. So the map is going to be, we're going to do decimal string to number. Actually, no. Yeah, decimal string. So these are going to have to be whole numbers. You can't have half milliseconds. And the key of the map is the time. Okay. And you'll see here in just a second here, the value of the map will be an array of actions at that time. So that's going to look something like this. We're going to do a bundle. It's going to be the channel name and then the channel value. And this will be fractal string to number. So this will give us a double, but it's an array. So we're going to do this. And so we're also calling this look in our, okay, hold on. You'll see in a second. Shift register, great, constant, then this map, and then there. Why do I have an error? Insert into, oh, that's map, great. So let me just, this is probably easier to show than to tell. What this gives me is a map where I didn't save this. Let's save it and rerun it. Okay. Where, again, the key is the value, is the time. And inside of the time, you have the action, basically, right? So chan 1, chan 2, chan 3. Awesome. And then, it goes on. And then at 500, it's just chan 3. So now I have, and maps, just by, again, not coincidence, but the way they work is they sort by the key. So this map is already sorted. So we are good to go there. So now, so the reason I do this build array here is, right, so the first time this runs, I add this line. Then the second time it runs, I'm reinserting and under that same key, both of these lines and so on. And so it kind of builds on itself with that shared key. All right. So then we just loop over our map, get our data out. Actually, we're just going to do a regular unbundle here. We're going to do an unbundle there. So, oh, okay. One more for loop. Great. And then again, we have this guy here. So we want to populate this type def. Bundle name. Well, boom. Start time. Boom. That's that guy. That's common. And then channels and values. Well, look at that. It happens to match. All right. So there we go. So this is us parsing the sequence file. And now we have our sequence data. So now I can just delete all this. I don't need any of that. Great. Control U. Give it an icon. We got 20 minutes. We're cutting it close. Sequence load. All right. so you can see like a lot of what I'm doing here is not so much framework stuff. This is just LabVIEW stuff, right? Like reading this file has, the only real framework stuff we looked at was the dependencies and the event. Okay, so then we go back to our process and we go to our sequence load function, and well, what do? We call the sequence load. So this takes that, and then our sequence path, remember that comes from here. And then we actually what we want to do. Okay, there's still a fair bit to do, but we want to just, namely, we just want to store this sequence. Great. Tab. And then last but not least, we want to be sure we call the sequence load function here, right? And then actually, also not last but not least, we want to store the sequence file in our data bus so that when we call sequence load, it can access it, right? So sequence path is here. So now normally I would demo this from the UI. In the interest of time, I'm going to skip that. But what we would see is it would call this function, and then this would be populated. So next step is to run the sequence. So what does that look like? So first we're going to have a new action, which is sequence start. And what this is going to do is it's just going to kind of initialize ourselves. So, and again, I'm kind of building on this without telling you the master plan in my head, but it should be clear by the end. So we have all of this kind of metadata that I populated, right? So sequence running is now going to go true as we are starting the sequence. Sequence start time, that's kind of our 0, right? We're going to get tick count. So this is in milliseconds. So this is when we started. Sequence path, we're not going to follow. Sequence next index, we do. You'll see why this is important in a second. We're going to reset this to 0. Create constant 0. And then we are going, that's it, right? So then, okay, now when we call sequence load, or when we call sequence.run, first we're going to load, then we're going to start. All right, now what? So what we're going to do, the way you're going to leverage sequences with this process is we're going to have what's called a sequence service frame. So in this process, the default frame when nothing's happening is you come to the event structure. And by default, the event structure has a -1 timeout, which means the timeout frame will never get called. We're going to change that. We're going to change our sequence pull rate to every 100 milliseconds. We're going to call the sequence service frame. And you'll see what this does. All right, so then now we have an action. So every 100 milliseconds, we're calling this sequence service frame. The way this works is we kind of just check on what does the sequence need to be doing right now. So remember we had sequence next index, and we have our sequence. Well, let's go. Oh my God, I'm writing them a strongly worded letter to change this back. I cannot believe they would do this to me. Anyways, sorry. All right. Boom. So this is the current step that we need to execute, right? And it has the start time and it has the channels. So then what we're going to do here is we are going to get the start time. Remember, we stored that. And we're going to check the elapsed time. So we're going to get tick count here, and we're going to subtract the current time from the start time. Now this is elapsed time in milliseconds. So then we say, is the elapsed time greater or equal to the to the start time, right? So let's say in this case, well, 0 is an obvious one, right? Is the elapsed time greater than 0? That's most likely going to be true. So let's skip that one. Let's just get this in the correct order again. But now we can say, is the elapsed time, if we're on step 2 right here, is elapsed time, and let's just elapsed time, comments are good, greater than or equal to 300. And if it is, well, we got to go do something, right? And what we got to do is we got to do this, okay? So stick with me. There's a little bit more. So what we're going to do here is we're going to do, I actually want to grab this. And so this is going to be the action. Great. So if I go back over here, service. So then we have conditional state. Yes, perfect. Okay. So if this is true, what we're going to do here is we're going to call a new frame. Great. Constant IO manager write. And this is just a helper function, conditional state. Basically, the output of this will just have the state on it, if and only if this is true. And then we also need to do a couple things here. We need to store the action, which is just this guy right here. Okay. Alrighty. So then let's go write one more function here, which is the IO manager write. Duplicate. And then we're going to go get we're going to do a couple things here. We're going to grab our action, right? And this has the list of channels and values. Great. And then what we also need is the IO manager. So how do we get that? Well, luckily for us, this is a little bit cheating, but I'm going to do it. It's inside of our class. Remember, it's inside of our dependencies folder. Boom. Or cluster rather. So now I have the IO manager, and remember, the IO manager has this lovely function IO write. So then I'm just going to loop over all of my channels that I need to write to, and I'm going to write them. So this right here, this is I'm like kind of going fast here, but this is the secret sauce, right? This is how subsystems in this architecture write to other channels. And we saw this in the UI. This is just the sequence doing it instead of the UI doing it. Okay, so this is almost done. The service needs a bit of love though. What we need to do is, one, we need to increment the next index, right? Because now we've executed this portion of it. So what we're going to do here is we're going to go to action. Excuse me, we're going to go to next index. And if this is true, right, if we're doing the write, then we want to increment our next index. Otherwise, so if it's true, increment. Otherwise, if it's not true, then we're still waiting for that to occur. And so we're not going to increment. So we're just going to leave the next index there. And then finally, if the next index is greater than our array size, that means we have completed our journey. The sequence is no longer running. So I'm going to just do a little bit of math here. Array size. So this is the size. So if my, how do I do it? So let's say, okay, so if this is 5, the max index will be 4. So if you hit, so yeah, if it's greater or equal, so if this value is greater or equal to this, then we are no longer running. So then it would be a not. Okay. And so what you can, so I'm not going to have time to do this today, but what you can do is, as part of the status, basically this is kind of the interesting stuff to publish to the UI, right? Are we running? What's our current step number? And what's our either current or next action? So this you could put into a public event and broadcast that. And then when you change steps, which is this guy, execute step, then that would be a good time to publish. Okay, so sequence running. We haven't actually used this yet, and I kind of actually forgot about it. But inside of here, in the timeout case, you only want to call sequence service if the sequence is running. Otherwise, just chill. So what we're going to do here, again, we're going to leverage that conditional state based on is sequence running. Okay, and then conditional state, boom, and so only do state if running. And so then, when the sequence stops running, you won't call the sequence service. And so that's why it's important when you call sequence start to set sequence running true. Okay, I think that's it. So let me run this, and then we even have time for questions. So what we want to do here is I'm going to just run this, and then we need to modify our sequence to actually get some good values. So if can I plot this channel, and then if I write a 1, it goes up. Oh, okay, cool. So we have this is writable. So we're going to do chan 1, and let's get another one here. It doesn't matter, right? This one, and then if we do a 20, great, that one works. Cool. So these we'll do just 3 channels here. And these will be the 3 channels we write to. So we'll do 1, 10, and 100 and 100, and then we'll do 2, 20, 200, and then we'll do 3. Sure. It might be kind of hard to read, but we'll see. So then we're just going to copy, 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 copy. And then, sure. Okay. So, drum roll. Let's just set everything to 0 here. And then we're going to select sequence 1. I have no idea if this is going to work first try, but let's try it. Holy crap. It works. Here, let's increase this.
Man.
Let's see. So 3 seconds, and then 5 seconds.
To watch Picasso in action.
So that's how you write a sequence.
Would be proud.
Yeah, first try. Like I said, I've written a lot of sequences, and this is a very simplified version. You can get a lot more intense, like we talked about early on about conditions and things like that. So, but yeah, so there's a lot more to consider, right? We talked about, okay, well, what if I want to chain these sequences? Well, I hope that you might be able to extrapolate what we did, because really it's the exact same thing. It's just adding an additional layer, right? So then you can have a different type of sequence file that does exactly this, except, on the service, you have another lap, right? So you execute this sequence, but instead of exiting, you increment your meta sequence index, right? And then you go to the next one, and you kind of rinse and repeat. But that would be very straightforward to add. Obviously, we don't have time in the 4 minutes remaining. But that's, yeah. Thoughts? I guess I'll shut up now.
Pretty incredible. Good work.
Thank you.
Yeah.
Thank you. First try, right? All right, that wraps up the Sequence Engine training demo. I hope you enjoyed. I hope you learned something new. Please feel free to drop a comment or reach out if you have any questions. Again, I really hope this was valuable for the LabVIEW community. Cheers and have a great day.